Hello there. Welcome to another episode of looking at rustlings, of working our way through the rustling exercises. So let's jump right into the error here. We've got an error that says missing type for const item, and this is variable 6 in the first chapter, or whatever we want to call it, for variables. And it underneath const number assigned to the value of 3, it has a little helping message that says provide a type for constant I32. Could not compile exercises due to the previous error. Okay, so let's jump over to the code here. And I think that the answer here is pretty obvious, that we can assign and need to, for a constant, assign a type like I32 should probably do the trick. And the compiler says that that's good. I'm just curious about how they wrote their thing. Did they expect it only to be I32, or could we have given something other than what the compiler recommends? As far as Rust code is concerned, it's valid Rust code, but also good to see that their little example doesn't require you to give like some very specific type when the question is broader. Okay, we'll finish compiling one more time. And this is really going to be a quick one because honestly, once you know how to do type annotations the way we just did, of just saying colon right after the name and giving the type with one of the available types that would be a valid type for whatever you're doing with that variable, then it works all hunky-dory. All right, so let's take a look at the hint, because I think that the hint might be interesting to read here. We know about variables and mutability, but there is another important type of variable available: constants. Constants are always immutable. They are declared with the keyword constant instead of let. The type of constants must always be annotated. Read more about constants and the differences between variables and constants under the constants in the book section, variables and mutability. We're reading that book as we go alongside of this, so we're not going to get into that right here and right now. But the other thing I want to take a look at is, of course, looking at the solution just to see if they did a similar solution to ours. Variables 6.rs. There it is. Okay, they did pretty much an identical thing. So we talked about in some other videos shadowing, right? But like, can you shadow a constant? And the answer, if I understand this correctly, should be no. Like, even if we were to be really explicit and say let number 32 equal 5 or whatever, I don't think we can do that. Mismatched type. So now the compiler's caught up with us. Constant defined here, expected due to this, expected U32, found I32. Number is interpreted as a constant, not a new binding. Help introduce a new binding instead. Other number, I guess, is just suggesting use another type. But even if we wanted to just assign a different value within the same type, I don't think you can do that with constants. I think that the compiler says you really can't change a constant, which is different from Python, that there are no true constants in the same way. So yes, we're getting refutable pattern in local binding error. Missing patterns are not covered because number interpreted as a constant pattern, not a new variable. Pattern is I32, min to I32, blah, blah, blah. This is like describing the type sizes, basically. Note, let bindings require an irrefutable pattern like struct or an enum with only one variant. For more information, check out the docs. The matched value is of type I32, so that matches. But what they're suggesting is to say, no, this is a constant you've defined, so define another variable. So let number underscore, for example, var of I32 type be bound to the value of 5. But we're not going to do that. I just wanted to double check that constants really are constants. Because, like, let's jump over to, well, yeah, anyway. I was going to show a Python example, but basically in Python, you can't really permanently assign stuff. Actually, I don't know what's up with my brain, but I was like, I'm not going to do it. And then I'm like, yeah, I'm going to do it. So what about constants in Python as just a point of contrast? If I got foo, all caps, and then I say that it's 3, there's just nothing that really stops me from doing that and saying, what's the value of foo? It's 5, right? You could use the type system and go from typing import, final, and then say foo final int equal to 5. And if you're in an editor, it might tell you not to reassign it, but you can actually just reassign it, and Python's just fine with this. So for better or for worse, Python's got a pretty wimpy notion of what counts as a truly constant value. There are other things you can do in Python, but I'm not going to cover those right now. It's not a Python tutorial. But just to say, as a point of contrast, if you're coming to Rust from Python or a similar kind of scripting language, what's that mean? It's like constants. Constants are constants, okay? That's the way it is with Rust, and I think it's mostly a good thing. You want to set something to truly be of value, and it is what it is, and it's not anything else. Okay, I think that's probably as much as I can think of off the top of my head to talk about constants. We looked at the example, we looked at the hint, and it's a pretty easy problem to solve. So I think we'll just move on. I will see you in the next video, and have a great day. Bye.